Hello everyone, I am Rahul Shandilya, and in this lecture for Digital Electronics Lab, we will discuss our first lab. This is the first screen of your LTS Spice simulator. This is free to download and install, so you can simulate the electronic circuit, even analog circuit on this simulator. So to start our first simulation, we'll just click on the file, click on the new schematic, and this is the screen. Here you can see a fine grid of dots. This is used to basically align our electronics components. So first we put some component, and the first component will be the voltage source. Right click it and put here 2 voltage source. Then we will click escape, then put here ground, escape, and then we will put our components to simulate, which is the logic gates. For example, we put first and uh, and here now on this circuit we can see there are two outputs. Basically the bubbles output is NAND gate, and without bubble output is here is the AND gate. So on the same symbol we can get AND and NAND gate. Now we can put more than one component. So let's put also the OR gate, escape, then put not gate. It is as inverter. So here not gate is mentioned as inverter, and then we can put XOR gate at last. So basically we cover all the basic gates, and NAND. This output is and this output is NAND, and this is OR, NOR. This is basically inverter, and here we have XOR and there XNOR. So let's say first of all, yeah. Now this we need to connect it with using wire. So here you can see pencil marks. Click on the wire. Uh, uh, then the second voltage source connect with by clicking and then stretching, again finally clicking, it is get connected. So now we can select this wire with the OR gate. Say let's and this. Now this voltage source also connected to this, and this voltage source connect to this. Now let's see, V1 is connected to buffer. Okay, this is basically our connections. Now we can label our output here. So basically, yeah, again we connect some wires basically. Uh, connect connect OR gate, click it and then right click it and right click. So this is I'm not connecting all the connecting, basic I will show you, and then uh, let's put some label on the output. Label here for star. The port type is output, and we are basically doing v1 underscore and underscore V2. Okay, now connect this level to here. You can connect this level, second level here, third, fourth, and fifth. Now we can change escape. Now we can change this by right click. It is not, and it is basically NAND gate. Okay, no, it is not, and it is OR gate. And right click, it is basically our NOT gate, and right click, it is basically our XOR gate. So we will level it. Now we just configured our in voltage sources, say and for digital logic we put it here pulse type of voltage. So V initial is, let's say, 0 volt, V on is say 5 volt, and T delay, we will put a delay of we don't want to put delay. T rise time is 5 nanoseconds. Let's see, T fall time is 5 again nanoseconds. T on, yeah, let's say 10 milliseconds. Okay, now T period will be double of it, 20 milliseconds. V1 is 20 milliseconds. It's not uh, 10, and it's 20. Okay, so it's a T delay, let's say 0. We configured our stage, so it is written here. Again we do some advance pulse 0, 5, 0, T rise 5 nanosecond, fall 5 nanosecond. T on here we put say 20 millisecond. Tab here we put say 40 milliseconds. Okay, cycle. So we can, it's we can say make it invisible, our configuration. Okay, and again make it invisible. Okay, so here is it. Now we can simulate it, say by clicking simulator. Stop time, say we have 100 millisecond. Okay, now so window simulation window is created. Now we can tile it vertically. So let's say add trace, the first one, the V1, say this. Okay, now now add a plot plane. Okay, we do it for V2. Okay, now we can do it again, a plot plane, add a plot plane, and connect, say, our AND gate. So here we can see again the V1, see the wire was break. I have connected wired basically. So this is the plot of VN1, this is the VN2, and then put probe here. So this is the simulation output, and we can again do it, say delete it here, add a new plane, plot plane combined with your OR gate. So here we can see the OR gate output, 1 1 1. It is 0 for, say, when both are 0, say on this here for example, both are 0, here OR gate is also 0. This is the end of lecture. In the next lecture we will discuss basically uh, how to make use NAND, AND gate and NOR gate to simulate all these basic logic components.